Okay, we're gonna do a little trigonometry activity here. For most of you, this will be review because you've already had the trigonometric functions. But I found that students really benefit from a good, thorough review of what trigonometry is, and we're going to do a little activity for it. And the reason we're going to be learning trigonometry is that we're going to be studying vectors. Again, and we've talked about vectors before. Vectors are quantities that have magnitude and direction associated with them. But now we're going to talk about vectors that exist in what we call two-dimensional space. Okay, and so we need to take those vectors and divide them up into their x and y components and blah blah blah. So we'll get to that in a couple of days, a few days. But for right now, I want you to do this activity with me. What we're going to do is this: we're going to draw a right triangle. Okay, and so here I've got. Oh, this is one of our sponsors for the robotics team. Okay, so I'm plugging them. And I want you to make this pretty big. This is going to be big, and just watch for right now. I've got protractors and rulers here, but I want to show you what to do first. So just watch, and then we'll do it. So I'm going to make a big right triangle. So the first thing I want to do is draw a horizontal line. Now, if it's a right triangle, what I want to do is make it, I want a 90-degree angle. So hopefully, yeah, I'm on screen there. All right. So I want this to be really good, really as precise as possible. So here's 90 degrees right here. All right. So I will draw this here. Okay. And now I'm going to make a hypotenuse here. Now notice that I just did this randomly. Okay. So in fact, I don't want everybody to have the same right triangle. I want people to have different angles. You can make it like 45 degrees or 30 degrees, 20 degrees. I don't care what this angle is, as long as it turns out to be a right triangle. And then what I'm going to do is this. I'm going to take this, and I'm going to put a little dot here, and a little dot here, and I'm going to make turn this into 3 right triangles. There's my first one, and then I'm just arbitrarily picking a spot. Here's another spot. So I line this up like this. See, there's a little thing there. That looks good. I just want these to be 90-degree angles. And so now I think you can see that I've got 3 right triangles here, don't I? I've got this one, which I'm going to call triangle A. I've got this one, which I'm going to call triangle B. And remember, it's the big triangle. They're all starting right here, and they go from up here and up here. And I'm going to call this triangle C. That's the big one. Okay. And now, you're used to thinking of triangles in like geometry class. You call this A, B, and C, right? Remember, the A was the adjacent leg, B was the opposite leg, and C was the hypotenuse. But we're not going to do that in here. What I'm going to do is I'm going to call here's the angle theta, and I'm going to call this x, from the distance from here to here, x. I'm going to call the distance from here to here, I'm going to call it y. And the hypotenuse I'm going to call r. Okay? Then what I'm going to do is I'm going to make a little chart here. I'm going to make a chart. I'm going to go A, B, and C. Okay, and see, I don't need to use a ruler for this. I can just do it by hand. It's faster. And what I'm going to do is for each triangle, I'm going to measure x in centimeters. and I'm going to measure y in centimeters. And I'm going to measure r, the hypotenuse, in centimeters. Okay? And then once I've done that, I'm going to start calculating some ratios of this right triangle. And what I'm going to do is this. The first one I'm going to do is I'm going to take my value for x and divide it by my value for r. So I'm going to go x divided by r. And then I'm going to do the same thing. I'm going to go y divided by r. And then I'm going to go y divided by x. I'm picking these three ratios to do for, you know, the triangles. Yes? Well, you know what? I will in a second. Well, no, I can zoom in now. You're good. Okay. Now I'm gonna do it for triangle A. I'm gonna do this for triangle A. And so what I need to do, oh, I can't use this one. I'm going to measure it in centimeters, and I'm going to be as exact as I can be. So here's x for triangle A. Now don't copy, you're going to have your own triangle, so don't copy it. But look, I measure this, and it looks like it's 4.1, maybe a little bit more than 4.1, 4.11. So x is 4.11. I'm going to try to get three significant figures out of this. Centimeters. Now let's measure y. So I put that there, and I look at that, and actually it's easier to see it on the screen, huh? This is 2.60. And then r, well, I'll start here and I'll go to there. Okay, and it looks like it's 4.9, a little bit more than 4.9, maybe 4.92. And by the way, notice what I'm doing here when I'm making measurements. This last little digit here, it's a guess. You're kind of looking at, it's about that. That's called the uncertain figure of a measurement. And whenever you measure, there's a little bit of uncertainty in your last digit, right? So now what I'm going to do is I'm going to measure, I'm going to take the x value and divide it by r. So you just get your calculator out. Where is it? Take out your calculator and just go, okay, x is 4.11 divided by 4.92 equals, and I get 0.835. Now, since these numbers have uncertainty to the third, on the third digit there, you don't want to, it's on the calculator. It's, well, here's the calculator. Now, here's the 0.835365854. It just goes on and on forever. Don't write the whole thing out, because you only know this to the nearest, third digit, the nearest hundredth of a centimeter, and that's a guess anyway. So this is going to be a guess as well. So you just keep the same number of significant figures. Then you do the same thing for y and r. For y over r and y over x. Just take these and divide them. You don't need to show your work on that. I'm going to assume that on a calculator you can divide. All right. Now do the same thing for b. Now I am going to show measuring b, because I have had students do the wrong thing. Here's the wrong thing. I have had students do this. They go, oh, okay, b is 3.5. Wrong. What do you want? For x for b, where does it start? Over here, it's from here. Look, here's triangle B, this whole thing. So you measure from here. So on mine, it's 7.70. It looks like it's right on there. So 7.70. And then I'm going to measure Y from here to here, and I'm going to measure R from here to here. And then I'll do the same thing for C. And then I want to calculate all these ratios. Okay? So do you all understand what it is I want you to do? Okay? What I want you to do right now is to draw this triangle and fill out this chart. And I want you to get it done before the bell rings. Okay? And then we'll take a look at what you did when we're done with that.